Hello, I'm Mrs. J, and welcome to my math class. Today we're going to learn about section 15.2. It's a reverse of a chain rule, and you use it when you have roots, powers, denominators, or exponents on E. And for our class, we don't really have to use the substitution because none of ours are more difficult than this rule will handle. So remember when we took the derivative of the chain rule, we did the derivative of the outside times the derivative of the inside. Well, to reverse that, you do the integral of the outside, and then you divide by the derivative of the inside, because then this will cancel with this. Let's try one. So the integral of the outside, we write everything down. We add 1 to our exponent, so this would become a 5, and we divide by that value and the derivative of the inside. And if we take the derivative of the inside, 2, plus our constant. This 2 will cancel with this one and leave 2/5. 2x plus 3 to the 5th plus c. Try another one. So in this one, we have a fraction. Whenever you have a fraction for the integral, you have to bring it up. So we have 2m plus 1 to the negative 3. Now we can take the integral. So we write everything down. We add 1 to our exponent. When we add 1, we get a negative 2. You divide by that value and the derivative of the inside, which is just 2 plus c. The 2 will cancel with this one and leave a negative 1/2. 2m plus 1 to the negative 2 plus c. And then you could bring that 2 down to the denominator if you wanted. It could be negative 1 over 2 times 2m plus 1 squared plus c. But I believe Alex will take either one. And not Alex, my math lab, but I will take either one also. Try another one. So the first thing we want to do is rewrite it. Now this part here, we're not going to do anything with this. Once we divide by the derivative of the inside, this should cancel. Sometimes the numbers stay, like factoring that 2 out. But the x plus 1 that would be left needs to cancel, or you have to use substitution. So this should cancel for our course. So when we take it, everything stays the same till we get to that exponent. When we add 1 to the exponent and get a negative 3, we divide by that value and the derivative of the inside. By the inside, it's the part that has the exponent. So it'd be 2x plus 2. Don't forget your c. Notice the 2x plus 2's cancel. And we have, if you want to bring that back down to the denominator, 1 over the negative 3 times x squared plus 2x minus 4 cubed plus c. Try another one. 3x squared e to the 2x cubed. Now, e's are a little bit different because remember, we didn't add or subtract the e's. We kept the whole thing and then multiplied by the derivative of the exponent. So instead, we divide by it. So we keep everything the same. And then we divide by the derivative of the exponent, which is 6x squared plus our c. This will reduce by 2, and the x squareds cancel. If the x squareds don't cancel, if this doesn't go, then you have to use substitution. So this is just 1/2, because the 2 in the bottom, e to the 2x cubed plus our c. On a test or a quiz, I would write plus c at the beginning of your paper because you're going to forget 1 somewhere. Try another one. Okay, so keep everything the same because this is e. We don't add or subtract. 1 minus t e to the 2t minus t squared. We're going to have a plus c. Divide this by the derivative of the inside. So we're taking the derivative of this, which would be 2 minus 2t. This isn't canceling. But notice if we factor out a 2, they will cancel. Or you could cancel them and it leaves a 2 in the bottom, if you notice that. But we could pull the 2 out. 1 minus t e to the 2t minus t squared plus our c all over 2 times 1 minus t. The 1 minus t's cancel and leave the 1/2 e to the 2t minus t squared plus rc. Try another one. Y squared plus y over 2y cubed plus 3y squared plus 1 to the 2/3 dy. First thing, got to move that up. We move it up, 2y cubed plus 3y squared plus 1 to the negative 2/3 with respect to y. Excuse me. Oops. So we're going to take the integral now, so we don't need the symbol. Okay, so then everything stays the same until we get to this exponent. So we have y squared plus y, 2y cubed plus 3y squared plus 1. And then we want to add 1. So when we add 1, we get a positive 1/3. We divide by that value and the derivative of the inside. When we take the derivative of the inside, we get 6y squared plus 6y, because you're taking the derivative of this part. This needs to cancel. Plus c. We need to factor the 6 out. So we have y squared plus y, 2y cubed plus 3y squared plus 1 to the 1/3, don't forget your c, all over. Pulling the 6 out, I'm also going to multiply it times this 1/3, which will make it a 2. Well, I guess I could put it to. We're going to pull out a 6. So we have y squared plus y. Let me move the C down so I can fit the answer. The y squared plus y's cancel. So on the top we have 2y cubed plus 3y squared plus 1 to the 1/3 divided by 6 times 1/3 is 2. And you could have put the 1/2 in the front instead. And don't forget your plus c. Try another one. You have the integral of the square root x squared minus 6 x and then x minus 3 dx. Well, just like the other one, you need to rewrite your radical first before you can take it. So it's just like before. X squared minus 6x to the 1/2 times x minus 3 dx. Okay, so this is the part where we're adding the 1 and dividing. X squared minus 6x. When we add 1, we get a 3/2. X minus 3 plus c divided by the 3/2 and the derivative of the inside, the part that has the exponent, so 2x minus 6. We can pull a 2 out of here. This part has to cancel, or we have to use substitution. X squared minus 6x to the 3/2 all over. When we pull the 2 out, we're left with x minus 3, which cancels. And these 2's cancel to leave a 3. So it's 1/3 x squared minus 6x to the 3/2 plus c. One more. T squared plus 2 over t squared plus 6t plus 3 to the dt. This is a special case. This is a natural log. Because all of these, remember the rule, n cannot equal a -1. Well, when we bring this up, it's going to be a -1. So we have t squared plus 2, and then we have t squared plus 6t plus 3 to the -1. So that becomes a natural log. The natural log t squared plus 6t plus 3, and that t squared, could have put it in the front. Because this part has to cancel, so it could be in the back or the front. Divided by the derivative of the inside. 2t, wait, something's not right. Oh, this was cubed. This was cubed. So be sure to make that a 3. Because this is squared, so this has to be squared when we take the derivative. 3t squared plus 6 plus c. We can pull a 3 out of the bottom. So I kept everything the same. In the bottom, I'm going to pull out a 3 so that it will cancel with this one. Now, if you can tell that these cancel and leave a 3, that's fine. Or factor it. So we have 1/3 the natural log t cubed plus 6t plus 3. Let's try one application problem. Number 39, it says the marginal revenue in thousands of dollars. So we have marginal revenue, and it's in thousands. From the sale of X MP3 players is equal to 4x times x cubed plus 27,000 to the negative 2/3. Part A. Find the total revenue function. So find R of x if the revenue from 125 players is $29,591. Okay, so first thing we need to take the integral to find revenue. Because this is marginal, we need to do the reverse. 4x times x cubed plus 27,000 to the negative 2/3 with respect to x. And this is x squared. Okay, this was x squared. It's hard to tell on my paper, but this was x squared. When we go to take the integral, keep everything the same and start with that exponent. So we have 4x times x squared plus 27,000. Then when we add 1, we have a positive 1/3. We divide by that number and the derivative of the inside. And the derivative of the inside is just 2x plus c. So this x cancels with this one. This becomes a 2, and when you flip this and multiply, you have 6. So 6x squared plus 27,000 to the 1/3 plus c. Now you want to be careful. So this 2 went into the 4 and became a 2. This is a fraction, so we flip it and multiply, and that's how I got the 6. Then they told us that $29,591 when 125 players are sold. Well, you got to remember this is in thousands, so divide it by 1,000 before you plug it in. So it becomes 29.591. And X was 125. So you want to plug that into your calculator. And when we plug that in, we get 209.591. Subtract it to the other side. And we get a negative 180 for C. So our revenue function, go back to here, 6 times x squared plus 27,000 to the 1/3 plus, well, it's a negative, so it'll just be a minus. Minus 180. So that's our revenue function. Part B says, How many players must be sold for a revenue of at least $40,000? That is a hint that once you get your answer, you have to round up or you're not going to hit the 40,000. So no matter what the decimal is, you have to round up. So we want to 40,000. Remember that revenue's in thousands, so you have to divide. So we're plugging in 40. So the first thing we need to do is add the 180 to the other side. So if we add that over, we get 220. So we just took this to the other side and added it here. Now we need to divide by the 6. That will reduce, so we'll have 110 over 3. Now we need to decide how to get rid of this 1/3. Remember, an exponent to an exponent is multiplied. So if we take this to the third, when we multiply these, 3 over 3 is 1. So we want to take this to the third and this to the third. And notice I'm not putting any of my answers in until the end because you want to keep the whole decimal. So we have 110 over 3 cubed equal to x squared plus 27,000. We're still trying to solve for this, so we'll subtract the 27,000 to the other side. And then we have to take the square root of both sides. So you want to plug all of that in your calculator. Third minus 27,000. And we get 149.319. We cannot have part of an MP3 player. Normally we would round this and have 149, but if we have 149, we're not going to hit the 40,000 that we needed. To get 40,000, you have to round up because you need this extra part. So it's 150 MP3 players. And that's all for this section.